Hi, I'm Brian Hune, and I'm a senior product marketing manager for Netscaler. In this session, I'm going to cover the risks quantum computing introduces for your business and why waiting could leave your data exposed. We'll also look at why stronger protection comes with real trade offs in performance and why Netscaler is uniquely positioned to solve that problem. So, before we go deeper into quantum computing and what it means for security, let's quickly look at how we got here. Seeing the progression makes it clear why this conversation is happening now. So, quantum computing started as a long horizon research back in the 1990s, mostly in government and academic labs. It was fascinating science, but well outside normal IT planning cycles. In August 2024, the US standards body, NIST, approved key post quantum cryptographic ciphers as the path forward for future encryption. This was an industry inflection point. It told vendors, governments, and enterprises start preparing. The next generation of cryptography is coming. Just a few months later, between December 2024 and February 2025, the major cloud vendors all announced progress on their quantum hardware programs with major milestones in processor development. Google with Willow, AWS with Ocelot, and Microsoft with Majorano One. Different designs, but the same message: serious and sustained progress in building usable quantum systems. On the software side, the ecosystem started adapting in the same window of a few months. New versions of Chrome, Firefox, and Edge introduced support for quantum resistant cryptography, allowing today's encryption to protect against tomorrow's compute power. And for a very good reason, but we'll talk a bit more on that later. Overall, this means that PQC isn't stuck in labs, it's already showing up in everyday client software. Now, in the 2030s, experts expect fault tolerant quantum computers to become viable, systems capable of breaking the encryption algorithms we rely on today. Organizations that haven't prepared won't just be playing catch up, they'll be dealing with the fallout of not preparing in advance. So, now that we've seen where quantum compute came from and is headed, let's talk about what's at risk and why it matters. Now, there are two major threats that come with the rise of quantum computing. The first is digital certificate forgery. Once quantum computers are powerful enough, they'll be able to break the cryptographic algorithms used to verify digital signatures. This will allow attackers to forge certificates, impersonate websites or services, and overall undermine the trust in secure communications. It is a serious concern, but it depends on the availability of fault tolerant quantum hardware, and we are not there yet. However, the second threat is much more immediate, and that's what's known as the Harvest Now, Decrypt Later attack, or HNDL. HNDL doesn't require a quantum computer today. Instead, it's about bad actors capturing encrypted traffic now, storing it, and waiting. Then, once quantum computers mature, all that stored data will be forced open and become readable. That means any sensitive data in transit today, like medical records, financial data, proprietary IP, could already be at risk, even if it's encrypted using today's best traditional algorithms. This is why preparing for post quantum cryptography isn't about reacting to future breakthroughs. It's about protecting the information that matters right now. So, post quantum cryptography, or PQC, refers to a new class of encryption algorithms that are designed to be secure even against quantum computers. The goal isn't to replace all cryptography, but to replace the specific parts that quantum computers could break. That means public key algorithms like RSA, ECDSA, or ECDHE, the ones used for key exchanges, and these are all the asymmetric algorithms you see on the left side of the visual. And all internet traffic relies on these algorithms today, which means all internet traffic that relies on them is viable to be broken into without PQC protection. What makes PQC different is that it's based on new mathematical foundations, ones that quantum computers can't solve efficiently even at scale. So, to put this in perspective, cracking an RSA 2048 with a classical supercomputer would take longer than the lifespan of the universe, around 300 trillion years. But with a powerful enough quantum computer, it could take just 10 seconds. That's why we need post-quantum cryptography. And importantly, PQC doesn't require quantum hardware to use. These algorithms run on the infrastructure that we have today, and they're already being implemented in modern software, like we saw earlier with the major browsers. So, right now, most organizations are starting with hybrid deployments, combining traditional key exchange algorithms with PQC ones in the same TLS handshake. That way, even if one method is broken in the future, the other still protects the session. This hybrid approach is already supported in Chrome, Firefox, and Edge, and it's what Netscaler supports today with MLChem based encryption. PQC isn't something you prepare for someday, it's something you can and should deploy now. So, Netscaler has always been different. Built from the start with a one-pass architecture that inspects, encrypts, and routes traffic in one streamlined flow, that design has delivered performance and efficiency advantages for years. And now, in the era of post-quantum encryption, it matters more than ever. In real-world testing of hybrid TLS handshakes, which means the old cryptography and the new PQC, Netscaler sustained high transactions per second with no impact latency. The CPU impact was only about 25% with a post-quantum load. The non-PQC portion of the handshake continues to be offloaded to hardware, reducing the software overhead. So these results reflect a platform that's already ready for the quantum future. But now let's talk about what this means in a broader context. So this third-party comparison tested Netscaler VPX versus F5 Big IP Virtual Edition across increasing levels of application complexity, from load balancing to full app security with policy. So the results speak for themselves. Netscaler used significantly less CPU across all test scenarios. And in the most demanding test, which was load balancing, policy, and application security, which is like WAF and stuff like that, F5 maxed out its CPU before reaching the 2.3 gigabits per second test that we were doing, as you can see in the blue box there, which forced the test to be throttled down to 1.2 gigabits per second. And even then, Netscaler used 64% less CPU. That means that a full load F5 CPU usage was nearly 3 times higher than Netscaler. So, what's the real problem for other vendors? It's not whether they can scale, it's going to be the cost of having to scale. Because no enterprise is going to tolerate performance degradation. They'll fix it, and they'll do that by throwing more infrastructure, more licenses, or more cloud compute with the problem. And that adds up fast. Netscaler helps you avoid that trap, not just because it performs better, but because our licensing amplifies those performance gains into real cost savings. You start with a platform that uses fewer CPU resources for the same workloads. And then, with the Citrix platform license or Universal Hybrid Multi-Cloud license, you can scale up with unlimited additional instances without incurring any additional costs. With Netscaler, there's going to be no need to choose between performance and savings. Now, it's not just theory. Real customers are already preparing and taking steps to prepare for the post-quantum threats with Netscaler. These quotes are from 2 customers, a cybersecurity provider and a financial services company. They highlight that PQC is a real and current priority and that they're genuinely pleased to see Netscaler supporting it as early as we are. And we've rolled out hybrid PQC support to a range of other organizations already. Industries that take encryption seriously, like airlines, banks, healthcare providers, and government institutions, to name a few. They recognize that the PQC transition is coming, and they want to start now while they still control the timeline. Netscaler gives them the flexibility to test, deploy, and scale PQC on their own terms, with full support across both hardware and virtual appliances, not just select platforms. Other vendors are still limiting PQC to their legacy products, with no support for their newer architectures. That's not why I say it's a future rate path. Netscaler is already delivering quantum-safe capabilities where customers need them most, giving them a trusted partner to start the journey today and scale confidently into tomorrow. So, I want to thank you all for listening to this presentation. For more details on PQC and Netscaler's support for hybrid PQC, check out our recent blog post on citrix.com or our 3-part deep dive blog series on our community site. And then to take the next step, talk to one of our sales representatives and start planning your PQC journey today. Thank you.